discussing rubber chemicals quality and handling. I think all of you know it's very important, the quality of the chemicals and how you handle it in terms of the quality of your products, as well as the cost, how you manage your costs. We have a number of experts, altogether 8 experts, and some of them are from the chemical suppliers, manufacturers, and some of them are from the manufacturers, rubber product or compound manufacturers. So we have a good blend of the experts here today. I'd like to invite our experts who are in the panel discussion. Let me invite one by one. First, I'd like to invite Mr. Colin Clark. He is a director of the technical sales at Stuttgart, based in Germany. Mr. Colin, please come on board. He has more than, I don't know, close to 30 years experience in the serving the rubber industry in terms of the rubber chemicals, and he knows ins and outs of the what's in the about rubber chemicals. So it's good to have Colin Clark as part of the panel. Welcome, Colin.
Thank you.
Now I invite our next panelist, Dr. Samar Bandyopadhyay. He's a business head of the Pukhraj Additives based in India. He has industry experience on processing, tire industry experience, at the same time also involved with the chemical industry business as well. So he has both tire and non-tire industry experience. Currently is as the business head for the Pukhraj Additives. Dr. Samar, welcome to the panel discussion.
Thank you, Piram. Thank you very much.
I invite Mr. E. Palanathan. Mr. E. Palanathan is not joined in a live session, but I had a discussion with him in separate session for him, and I will show you his contribution for this panel discussion as a recorded format. E. Palanathan has more than 35 years experience in the rubber industry, both on compounding and processing side. Well experienced rubber technologist. So it's a pleasure to have EP as well as part of the panelist. Now I invite Mr. Kishore Karkar. He is currently technical and marketing director at Finorchem, used to be Merchem, and he has close to 40 years experience, I guess. He worked for the Lanxess Bayer before, and currently as a technical marketing director for Finorchem. It's a new name. I will ask him to introduce about that Finorchem later on during the panel discussion. We have Mr. Ramaswamy Sundar. He is a managing director of the Swan Elastomers. This is one of the leading companies offering a service on the custom rubber mixing. And entrepreneur, well experienced. So, Mr. Ramaswamy, welcome. Now we have Mr. Bharat Sharma. He is the president of the taking care of the corporate technical services, as we see the TWC group. He is not joining a live session, but I had a conversation with him about this topic, so I will show you our conversation as a recorded format in this session. Okay. He's also well experienced rubber technologist. He worked for the Reliance, ExxonMobil before, and well experienced rubber technology. So his contribution is very useful. We have Mr. Hamid Iftikhar from Pakistan, works for the Panther Tires in the position of senior manager of the compounding and tube division. He has more than 15 years experience in the compounding and tube division. So as you know, tire company, so he extensively uses rubber chemicals. So we like to get his experience about rubber chemicals quality and handling. Hamid, welcome to the program. We have Mr. Salut Lavsettikul. He is a business development manager for the Sunny World Chemicals. Sunny World Chemicals is one of the leading rubber chemical suppliers in Thailand. I think they serve lots of companies, tire and non-tire companies, providing the various rubber chemicals. They're also involved in the plastics and coatings as well. So Mr. Salud has more than close to 15 years experience serving the rubber industry, and so his contribution will be very useful for the panel discussion today. So we have all the, we have all the experts here. So let's, get started. I'll give you some kind of ground rules for all of them to, to share their experiences. And let's look at everybody's here, and I'd like to request everybody to open their cameras. Okay. Mr. Sundar, please open your camera too. Kishore Katkar, please. Somebody here. Okay, all good. So all of you, welcome to the panel discussion on the rubber chemicals quality and handling. I'll just give you some objective of this panel discussion so that I kick the ball and so that you guys can roll it and have a very useful discussion for the benefit of the rubber industry who are joining the session today, and also in the recorded format later on also. The objective, I think, rubber chemicals play an important role in rubber products, of course, as usual, but it's important the quality issues and very significant in terms of the quality, whether it is a properties improvement as well as the cost wise. So what we are trying to address in this panel discussion is that quality management issues, good practices as well as the bad practices. What industry doing, what kind of bad practices you see in industry, as well as from this both supplier point of view as well as the manufacturer point of view. So I welcome you all for this panel discussion. May I invite Colin to come forward to share your experience about the rubber chemicals quality and handling. You are being in the rubber chemical industry for, I can say, lifelong in experience time, is it? So let's get started, Colin.
Yeah, Param, thank you very much. It's a pleasure to open the batting, if you like. Good evening, everybody. Namaste, Sawadee Kap. My name's Colin Clark. I'm technical sales team member for Schil and Silica Structol. We're a producer of process additives, rubber process additive chemicals. Actually a global company, but two operational centers in Hamburg, Germany, and Stowe, Ohio, in the US. I'm actually based in the UK at present, and normally very regularly traveling globally to meet all of you, and happily looking forward to do that again in the near future. So it will be a pleasure to travel to India and to Thailand. Yeah, Param set us a very nice question there, quality and handling for rubber chemicals. For us, quality goes much further than just saying simply quality. I mean, it's taken as a given that the product supplied must conform to a certain specification. So, you guys might say, I want a certain melting point or an ash content or whatever might be written on the specification, but that actually doesn't tell us anything about the real performance of the product, if you like. So what we would break quality down to be the fundamental quality of the product. Is the product pure? Is it fit for the purpose? But actually more about the performance of the product, the performance of the chemical within your compounds. Do we have the right product? Do we have the right performance level of the product in your compound? And can we offer that as a supplier? And I think I speak for all suppliers here. Can we offer that consistently, uniformly with a high precision to our customers? And to do that, then we face challenges, and we like to take those challenges really on board. We in the field of rubber process additives, we really recognize the fact that these chemicals are not not mandatory for your rubber compounds. I mean, we heard about the natural rubber situation. That's a must. So most rubber compounds, you need a polymer, you need a filler, you need a cross-linker system, maybe you need some plasticizer, you need an anti-degradant system. And then there are a whole bunch of other chemicals which are optional. Tackifiers, release additives, process additives, activators, waxes, other lubricants. They bring special performance characteristics to rubber compounds, but they are optional. You may find that you can adjust your process to eliminate those. And so it's our job as suppliers, as responsible suppliers, to have this dialogue, and actually this is a dialogue, and we really appreciate to do this, to talk with our customers, to understand the changing requirements of the customers, and to demonstrate how additional products, or let's say the fine-tuning of a compound, can be done to the end user's benefit. There's always a demand for cost benefits calculations, and we understand that very, 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 very acutely in our company. We spend as much time developing chemicals to have the right performance criteria. So to have, of course, the highest purity, the highest uniformity. We work very closely with our raw material suppliers. We have a selected supplier base, predominantly European centric, although of course we operate globally and we know the global situation. But we work with our suppliers to have very high uniformity for chemicals, and then to translate that into the required performance criteria. So as much as we develop chemicals, we also develop the applications for using those chemicals. So I think it's very important for suppliers of chemicals to work with their customers together, to develop the application, to evaluate that application, and to show the real benefit of the chosen chemical in the application. So what would be then the win finally for the customer? And for us, that means going to a rubber lab, going into detailed trials regarding the mixing, the downline processing. We're producing process additives, so all of the downline processes need to be modeled, need to be simulated, and then finally looking in detail, and increasingly more in detail, to be honest, at the finished properties of the rubber article. So do we achieve the specification of the final compound? Does the compound performance really match what the customer wants to have? And so for us, it's a more holistic approach, I would say, to providing quality, to work hand in hand with our customer, to understand the requirements, and to demonstrate the performance level of that product in the customer's application. And this can only be done through a close and detailed dialogue. And this is something that I think increasingly people recognize is an important relationship to have between the supplier and the end user. If we think about handling of chemicals, this is also a very challenging, very important and very challenging issue, I would say. The increasing regulations regarding classifications of chemicals. We all know very well about European REACH. There are other legislations globally showing up. We have Korean REACH. We have regulations very severe or very, very closely controlled in China, for example. And so the demands to satisfy the local, regional and international legislations or regulations concerning chemicals become more severe. And how can we then handle, how can we mitigate the risk exposure scenarios for the use of those chemicals? And this can be done by things such as encapsulation, by pre-weighing, by protecting the chemical or limiting the exposure of the chemical to the end user, and of course by changing finally the chemistry. So we work very hard to eliminate all SVHC components, for example. Where it's necessary to have a chemical with a classification, then we look to special packaging, maybe pre-weighed sachets or some kind of encapsulation. A lot of use of dry liquid technology, where we can damp a powder with a liquid, or we can adsorb a lot of liquid onto a granular material to enable a better handling of that. And certainly to look at sustainability. So our packaging sustainability is really high to our agenda, I would say. So recycling of packaging, the transition more towards big bags or super sacks of material, the use of the, I'm not sure if you're all familiar with the Goodpack system. So Goodpack is a containerized crate system where you can load, for example, big bags into metal containers and then double stack those containers. The metal crates are completely returnable. Goodpack operates a system where you can collect those packaging and return them. So there's zero packaging waste involved. And this is a very efficient way to deliver chemicals in a more bulk way for the bigger users. For smaller users, then of course, transitioning perhaps to pre-weighed bags or to pre-dispersed chemicals where we have some kind of carrier system to protect that chemical and to ensure the chemical doesn't contain a high degree of binder or inert material. So the customer gets the maximum concentration of chemical in a dust-free and easy handling form, I would say is part of the packaging demands or criteria that we try to focus on. Yeah, that's what I would say as an opening statement. I'm really looking forward to debate this topic with my peers online here, and hopefully we can receive questions and feedback from the audience. This would be really great because I think only through this kind of really open engagement and discussion can we all learn together and develop new ideas. So yeah, thank you for giving me the chance to open the debate, and I would throw the ball back to you, Peram, and look forward to hearing the views of others on this panel. Thank you.
Thank you, Colin. Excellent. You give an overview of what you are doing as Strict Code. You may invite Mr. Sundar, Ramaswamy Sundar. He is the managing director of the Swan Elastomers. Mr. Sundar. Okay, probably is unavailable now. Okay, let's invite the Dr. Samar Bandyopadhyay. He is the business head of the Pukhraj Additives.
Peram, I fully agree with what Colin has said so far, because without the customer, the supplier is nowhere. And in fact, we learn many things from the customer. As a supplier, sometimes we are teacher to certain customers, but to certain customer, we are the learner. This is the situation. And we learn about our products from the use of the customer. And customer gives the right feedback, whether my product is suitable for them or it is not suitable. And learning from one customer, we share our experience to the other customer that you can get benefited by using this product. So it's a real good learning. And we come to know about the beautiness of our product through the customer. Colin, do you agree with this statement?
Absolutely, absolutely. There are many examples that we all can know where customers tell us something surprising about our product, maybe positive surprising, maybe also something to think about where we see some shortcoming or something like that. I mean, we try to go very closely to our customers. Okay, I'm a technical service guy, and I'm proud to say that our technical service team is working hard on that. I've done the same job for 30 years, and I'm really pleased and proud to do that job because it puts me right in front of the customers, and every day I hear something new from a customer and get a new perspective. So really only by talking and close dialogue with our customers on every level, maybe on a very high scientific level with some kind of NDA or agreement, or on a casual interchange where they say, hey, did you know this or that? I said, oh, that's great. That's good. Yes, without our customers, we're nothing, and we learn from our customers. So fully endorse your statement. Absolutely.
Thank you, Colin. And many good things we come to know about our products, and which we advocate to the other customers that if you use this material, you will get benefit out of this. And this learning we get from a certain customer. And not only that, somewhere to the small customers, we have also to tell them what benefit they can get out of using the products. So this here we advocate, and here we like a teacher for them, and say that if you use this material, you can get benefit. And again, if we take the feedback from them, we come to know whether what we have told those are right or we are wrong. And as Colin said, Colin and we, Pukhraj Additives, we are in the similar business. And I fully agree with Colin that whether you use processing additives or you do not use, it is up to you. And we have to advocate that if you use, you get certain benefits. And over the years, Colin has done that job, and I am doing for last 6 years. And I learned a lot from Colin in this processing additive business through his different presentations in the different conferences. And practically these processing additives, what I have found, they are good. And they give a certain benefit to the our product manufacturers. And fundamental thing is that some basic requirement like polar, non-polar, saturated, unsaturated, this concept should be clear. Otherwise, you will have lot of difficulty. If you try to mix saturated rubber and unsaturated rubber, then there will be some problem. If you try to mix polar and non-polar rubber together, there will be some problem. So this concept, polar, non-polar, saturated, unsaturated, must be clear to the customer. And if they are not clear, then as a supplier, we have to tell them that you must not use this type of rubbers together. Like people, they try to use natural rubber and EPDM. Okay, natural rubber is a highly unsaturated rubber, whereas EPDM is very less unsaturation, and maybe 1 to 6% unsaturation. If they try to mix them, they cannot mix beyond some level. Otherwise, there will be problem in the curing or in the cross-linking mechanism. One rubber will get highly cross-linked, and the other rubber, because of less unsaturation, it will get less cross-linked. And lot of adjustment required in the cure system. Here I want Kishore to comment because Kishore is from the chemical side, rubber chemical side. From the curing standpoint, he can add a lot of value addition.
My life. Can you hear me? Yeah. Okay. Throughout my life, I am with rubber chemicals, start from manufacturing to application to the sale. So almost 44 years. Only 5 years I was with ISRL, that is SBR. But I am basically rubber chemical is my hope pitch, you can say. So coming to the I think Prevan Sara mentioned about Finorchem, just to highlight. Earlier it was Merchem, and Acmechem took over this Merchem company. Then Acmechem merged with Merchem, and now we decided a new company name, Reach Aries, as Finorchem. So Finorchem is a joint of Acmechem and Merchem. So product ranges remain same. Thank you very much. So coming to the rubber chemicals, I think the rubber, whether it is industrial product or the tire, is a mixture of so many ingredients. And the rubber chemical is a very important part, though it is a very small amount. Among that, accelerators, antioxidants are a really small amount, but the performance wise, whether it is a processing, whether it is a curing, and the subsequent performance are very important. I will touch 1 or 2 points on the rubber chemicals. One, I think Collins just mentioned about reach and something like that. So I think that point is very important, because the tire industry, they are well aware, but I think when we talk, I think more non-tire people are more interested to know about this. Last so many years, people are talking about reach, they are talking about nitrosamine issues, handling issues. So, but supplier has come up with a new product, which are reach compliance, which are nitrosamine free. And obviously performance is not one-to-one, but the suppliers can guide you to replace the products which are to be discontinued because of REACH, because of nitrosamine, whether it is sulfonamides like MBS, which is made of from the secondary amine. As you know, sulfonamide is a condensation product of MBTS and amine. So those products made from primary amine and tertiary amines are safe, but those products which are made from the secondary amine, particularly morpholine, these are likely to be carcinogenic. But obviously MBS was a very good product, tire industry was using. Now they are phased out, so obviously non-tire has to also follow the same. There is a safe options are available like CBS, TBBS. Obviously when you are using, some fine tunings are required and suppliers are there to help you without much modification required in the formulation. They can guide you for the processing point of view as well as from the performance point of view. So this is very important for that. This is not only for the sulfonamides, but there are some other secondary accelerators are also there, like TMTD, TMTM. These are also likely to be carcinogenic. So these are slowly being phased out. Tire companies also phasing out, and non-tire industry. Particularly when I'm talking about the Indian subcontinent, or maybe Far East, there are still people are using it. But when you are exporting this product to the country where these products are banned, then they have to find out the safe option like TMTD, TMTM. These are also made from the secondary amine, but TBZ TDs are available. Then there are the thiocarbamates are there, ZDEC, ZDBC. I'm not going in the detail of the formulation and all this. So ZDBC is available. So what I'm saying, the supplier has come with the options, but obviously because of the molecular weight difference, the dosage required for these new chemicals will be different than what they are using for the existing chemical. So there is required, some fine tunings are required to get the same processing property and same performance, where supply level technical service will definitely help you to guide you without any problem in your formulation. So this is very important from the safe. There, I think the list is going on. I think there are thiophosphate has come in order to replace in the EPDM compound, because EPDM, as you know, it is a slow curing rubber. You require many accelerators. Then the solubility limit is also there in the EPDM. So you can't use higher than the solubility limit, then it will blooms out. So all these problems are there when you're talking about EPDM. But then what are the options are available? So there are a lot of options are available. Like I said, thiophosphates are available where high solubility is there. So we will not go in detail of the one-to-one, but we can guide any customers which are facing this problem. They want to replace existing chemicals. I'm talking about accelerators, to safe accelerators without much losing any performance. Then coming to the handling part, as I said, handling is also very important. As I said, I will touch very important is the sulfonamides. Sulfonamide is basically the condensation product of MBTS and amine. As it is a condensation product, it is also susceptible to the atmospheric heat as well as the humidity. So when there is these products are exposed to the high temperature, high humidity, high ambient temperature, this product get decomposed partially. So again, we'll go back to MBTS amine. But why people are using sulfonamide over MBT and MBTS? In order to get higher scotch safety, slow cure rate, and faster cure, the lower cure time. If you use a fresh product having a very good stability, then you get a very higher scotch safety, very cure rate, and very good performance. But this product, if originally quality wise is not good, quality means what? Sulfonamide is quality go by the methylene insolubles or free amines, because free amines are there. So it should be have a very low free amine, or we can say a zero free amine, and the methanol insoluble, which is nothing but MBTS, is low as far as possible. But however, during the storage at high humidity, particularly in India and the Indian subcontinent and the South Asia, where the ambient temperatures are very high, this product, if it is not properly stored and get exposed to the higher temperature, particular high humidity, these products are getting deteriorated. And what will happen? When the products are deteriorated, it will get converted to MBTS and the amines. So obviously your scotch safety will go down. So your product, when you are doing the processing, you will find the scotch safety is there. Maybe the compound will get scotch at the mixing mill or in the internal mixer or during the shape operation, during the hoses or during the tire. So this is very important. We can guide you. We are not going in details about this type of products handling, how to handle this. But however, so you have to consider that proper good supplier, and then while buying the product also, you have to see the properties like methanol and amine. Melting point ash is a general specification. Most of the supplier will match, but very important for the sulfonamide is the methanol and the free amine. And after that also, the storage stability is very important. You have to keep properly ventilated warehouse so that the product can be stored. Don't carry the inventory for long. Maximum 6 months is the time, but I will advise to consume within 3 to 4 months in order to get a better scotch safety and a better processing. Then coming to the handling of product, because nowadays people are talking about scotch safety. Sorry, people are talking about handling, about the human factors, environmental factors, and these are chemicals, are hazardous chemicals. Without that, you can't work it. So now a lot of options are available, like granules are there, pellets are there, microgranules are there, polymer bound products are there. But depends upon the economy of the product, as well as the depends upon the requirement of the product. You have to use the product, because when you are using the pellets, the hardness of the pellet is very important. If the product is not dispersed properly, so one side you want to use pellet because you want to environmental good, then you don't want the powder in the environment. The operator which is working on the mixing or intermediate should not get exposed to the powder. These are good, but the basic from technology point of view, the product has to be dispersed uniformly in the final compound. So you have to ensure that this product has to be mixed. So powder is better, but obviously powder, dust powder is there. Now oil coated powders are available, granules are there. So pellet has to be hard, but not enough hard so that it should not get dispersed. Then you have to see the melting point of that. If melting point is low, so your dump temperature is around 150 and 160. If the melting point of any ingredient, whether accelerator or antioxidants, are lower, then it gets melted. But if the melting point high, maybe 170, 180, then the accelerator or antioxidant will not get dispersed. Then you have to take more precaution about that. Maybe you have to do the master batch with the polymer. Maybe you have to use polymer bound accelerators or antioxidants. So these are all the precautions you have to take during the mixings and all this. Sometimes we are talking about TMQ. It is a resinous material. If you add at the end, it will not get dispersed. So we advise to add this TMQ in the beginning of the mixing cycle when the viscosity is very high of natural rubber or synthetic rubber. So shearing force is high. So these are all precautions to be taken during the handling. Thank you. I think this is just preliminary introduction I have given. Any other question I can answer, please. Thank you.
Thank you, Mr. Kishore. May I invite Mr. Sundar, the manufacturer point of view, when he is a custom rubber mixer. Sundar, please.
Yeah. Good evening and hello to all of you. I just wanted to bring in a perspective of manufacturing and the user perspective. There are about 3 or 4 issues which I wanted to just highlight. The first is that of shelf life. What we see as a shelf life of these chemicals, usually there is a standard shelf life which is mentioned, which is time based. It could be either 3 months or 6 months typically, which is mentioned. And in my experience, I find that this is more of a guidance, rather than any hard constraint in terms of whether the chemical will be as effective or not after that particular date. To me, as a practitioner, I've got about 6-7 years experience. This shelf life mentioned in the pack seems very arbitrary. And it does not spell out what exactly are the preconditions by which the effectiveness of this chemical is there or not there. It's more of a guideline kind of a thing. The reason why I'm saying this is that as a practitioner, you will well imagine that we don't really go by this shelf life 100% because of certain economic conditions or because of some shortages or some emergencies. We do tend to use the so-called expired products. okay, which is say 8 months, 9 months to 12 months, sometimes even 18 months and so on. And depends upon the dosage and the application criticality. Sometimes we don't see any major variation in the properties, though it is a so-called shelf life. While it is our earnest attempt to follow this shelf life very meticulously and to the T, but commercially and also practically, I find that the shelf life mentioned is very arbitrary, and there has to be certain inputs coming from the manufacturer in terms of what really happens that will hamper the effectiveness of the chemical. Is it going to be oxidation due to exposure to atmosphere? Is it some hydroscopic reaction due to moisture, sunlight, UV radiation? What is it that really determines or drives the shelf life? Because if I know as a practitioner that these are the factors which can enhance shelf life, then maybe I can take certain conditions in my storage or in my handling which can extend the life of these chemicals. I don't think there is anything written in stone that this particular date something is expired. I don't think that is going to happen. The reason I'm mentioning this is that certain chemicals are used in very small dosages, and sometimes because of market volatility, suddenly the demand changes, and when such things happen, 3 months, 6 months just roll over, and no practitioner will be in a position to write off these chemicals, which are quite expensive also. When it comes to a push or a shove, I would rather take the risk of using a old chemical rather than writing it off. The cost of writing it off is more. That's the way we all wait. We are not going to be so strict. But at the same time, we should know the risks. We should know the risk of whether the effective. How do I check the effectiveness of a chemical? I can always do a small batch and test it out. But other than that, is there any other way to find out how to enhance shelf life? So this is an issue which I thought, from a manufacturer and from a chemistry, it's more to do with the chemistry part. And I would definitely want to gain knowledge in terms of what really happens to a chemical from the time that it is packed and to the time it is used. And an ideal world is not ideal. Of course, 99% we use fresh chemicals, but what happens to those 1 or 2% of those things where sometimes consciously and unconsciously we exceed the so-called best use date, which is a hard constraint. So that is one thing that I thought I should bring about. I don't have any answers. As I said, many times we take a chance, or many times we try to use that chemical in a small batch, test out the properties, and then clear it for mass production. But some sort of a scientific approach is required to actually determine what this shelf life is all about, and some deeper understanding would be helpful because it has got direct commercial implication as well. Yeah. Second issue is that of pack sizes, and this is an issue again coming from a practitioner standpoint. The velocity or the speed of consumption of some of the chemicals is really very slow. Of course, when it is fast, it doesn't matter. You open a bag and it gets consumed. But some of the things like peptazole, peptizers, or PVIs, etc. By design, the formulation the dosage is very small. So in those cases, we have seen in some cases like MGO, when there is a bag, say for 20 kgs, but inside the 20 kgs, there are sub-pack sizes of 1 kg or 2 kgs each, a secondary packaging. I think this should be very helpful in especially slow-moving items, where we will open the big bag, say 25 kg bag, but there is maybe 5 kg bags inside, which we don't open until we reach that particular 5 kgs or 2 kgs or whatever it is. And this won't, if you consider the cost of the chemical, this secondary packaging will not add too much of cost. And I'm sure as a practitioner, I would probably consider at least sharing the cost of the secondary packaging, or it's already inbuilt, because anyway, I think the costing and the margins are quite comfortable. So I think some sort of a secondary packaging would definitely be useful for those chemicals which are inherently slow moving, and that any conversation with a practitioner or any conversation with a formulation or a compounder will tell you which are likely to be a slow moving item, especially those which have low pHR dosage in the formulation. So this is something that I thought will be very useful, because many times we see in our shop floor, we open a pack and then we realize that either we need to reseal it in some way in a very crude and rudimentary fashion, or it is exposed to the elements. So I think this is something that we might want to consider as a norm to bring in secondary packing within the larger bag. The third issue, which is increasingly being asked by customers, is the certification of RoHS and REACH compliance. And many times we are baffled by this question, because there is so many chemicals. At any point in time, a practitioner is dealing with up to 100 different chemicals and ingredients. So which is RoHS compliant, which is REACH compliant, and what is the percentage threshold, if there is, by which the detection will happen? I think that is an important literature or technical information which is increasingly being sought by end users in terms of the RoHS and REACH compliance. So while MSDS and product data sheets is available, I think some specific information about the RoHS and REACH compliance will also help to build confidence with our customers. In fact, we could provide these certificates or information so that it gives confidence, because many times we cannot do the 100% testing. We have to rely on the information given by reputed suppliers. In fact, that's the reason why we buy from reputed suppliers, so that we can take their word and then we can go and use it with confidence, without ourselves doing much of the testing. To be honest with you, as a practitioner, for in RM, we have elaborate testing for various things. We do testing for polymers, we do testing for carbon black, oil, other things. But most often than not, and I can tell from my own experience, I'm not sure how the overall industry is, but when we buy a reputed chemical from a reputed manufacturer, we almost take it into like a green channel, like immigration. We don't really do much of testing in-house. While there are testing facilities and methodologies available, like for example melting point and all, but for sheer lack of bandwidth in terms of resource availability or time or whatever it is, usually this is bypassed because again, this is where again the responsibility and the reputation of the manufacturer goes a long way, because while it is important to do the testing, but on a practical basis, many of these chemicals goes through and directly it is open consumed, and many times the problem comes to highlight only when some issue is highlighted after the product is used. So this is something that we would like to appeal to the manufacturers. The last is, Mr. Katkar, raised this issue. Some sort of a broad-based, authentic information about the carcinogenic nature of some of these products. Because while we would like to avoid 100%, we don't want to put anybody at risk, either our own shop floor users or our end customers. But many times we feel that there are no substitutes, or because of commercial reasons. Again, like for example, Mr. Katkar raised the issue of EMT versus TDZ TB. But commercially, the price difference is almost 1:2 or 1:2.5. Okay. So these are some of the things that we would like to know exactly in terms of any technical literature is there. Who is the person or who is the agency who can give authentic information about the the carcinogenic nature? Because this is if it is carcinogenic, why is it still manufactured? If it is so, if the industry is conscious about the carcinogenic nature of a certain substance, then why is it even manufactured? You should come to say that in the next 12 months or 18 months we will discontinue this. Okay. So what really is the nature of this carcinogenic substance? Is it proven, or it is still a hypothesis, or it is, on what basis are these? Because sometimes it's a very loose discussion, and based on the which side you are on, you will tend to push your agenda forward. As if I want to push a TMT, then I will say no, in the small dosage it's okay, it's not yet proven. So is there a hidden agenda in some of these things? I just sometimes no, these are practical things. So is carcinogenic being used as a hidden agenda to push certain things? So that is something I would like to know, whether there is any detailed literature or some study or something which is publicly available, which everybody will come to a common forum. So these are some of the issues which is there, and these are some of the issues which I thought I'll call upon this public forum. Just to, I'm not providing any answers or something, but I thought it is pertinent for us to raise these issues which are practical in nature, and we routinely cross over on the non-compliance mode. To be honest, as a practitioner, whether it be in terms of the 3-4 issues which I've raised in terms of shelf life, or carcinogenic nature, or ROHS, or pack sizes, how we handle it, and so on. These are routinely we bypass the line, and then we go to the other side and come back on the line of compliance. But we would like to know what are the risks in terms of what we practice and what really is the implications of our actions. Yeah.
Thank you, Sundar. Wow, well, your points are very much valid. I think I will ask Colin to address first. After that, Dr. Samar and also Kishore Katkar, one after other. He raised 4 important issues. So try to be brief, and so that everybody has a chance to share. Colin, go first.
Sure, great, thank you. Yeah, really appreciate the input there from an end user. You're right. You're absolutely right to raise these questions, and they're valid points. If I look at the points you raised, if I took them actually in reverse order, so you were talking about carcinogenic and, let's say, toxicity of chemicals, and this is a very evolving situation actually. Chemicals that were considered safe 5 years ago, today with the greater understanding and new analysis may fall into certain classifications that didn't exist for those chemicals years ago. If I look at our own company, and we don't really have a lot of hazardous chemicals. We are not handling the accelerators or the anti-degradants, which have let's say, some of the basic inherently more advanced chemistry, if you like, which can result in things like nitrosamines. But in our company, one of the fastest growing departments over the last 5 years has been what we call CRA, Chemical Regulatory Affairs. And this is a team that work with the authorities. So in Europe, we have the ECHA, the European Chemicals Agency, responsible for REACH, and work together with customers to provide all of this registration. Quite often, we develop a new chemical, or there's a new chemical developed. Somebody has to register that with the authorities and then prove that this chemical is safe under the conditions it's going to be used. So there's a kind of lead registration and a risk analysis carried out of the exposure. So are the people going to eat it? Are they going to contact it on the skin? Which kind of environmental exposures are done? And actually these studies take a lot of time to do and are really quite detailed. So I fully agree with you that what is considered now to be a hazard, let's say an exposure hazard, might not have been the case 5 years, even 2 years ago. So it's a very changing, dynamic situation. I mean, we're hearing stories now about 6-ppds, and as an antidegradant that might fall into the class. We know of other chemicals as tachyphyres and other chemicals which were used as components in peptizers, for example, which now start to come under new scrutinies, let's say. And so it's important for all producers, all suppliers to work on that and to really keep their customers informed with regular updating of information exchanges, to make sure that the safety data sheets are updated, and really to direct the customers to the resources, the information. So for the European situation, you can certainly look at the ECHA website. That's a publicly available website where you can type in the name of your chemical, and the website will tell you what was done with that chemical. So is it safe? How can you use it? Who registered that chemical? How it can impact the workers or the environment? And I think the industry as a whole is working hard to eliminate the risks and to mitigate those risks. But you're right, not all chemicals can be eliminated at the same time. I think back to years ago when zinc first became in focus, the use of zinc in rubber chemicals, and this was also a European situation. European authorities discovered that the tire debris on the road, of course, then tires are running on the road. There's a lot of rainwater in Europe, particularly in Scandinavia, and this water was washing the tire dust and extracting zinc compounds into the water table, and the fish were dying. Oh, this is a terrible thing, and we must eliminate zinc. Actually, then a lot of people did work to say, okay, what's the alternative cure activator if we don't have any more zinc oxide? And the answer is nothing. You cannot eliminate zinc. I mean, you can, but what are you going to use? Cadmium, tellurium? Okay, no zinc, but the alternatives are more toxic than the zinc. So basically, no zinc. So the end result in Europe, for example, is today our zinc oxide bags have labels showing dead fish. So zinc oxide will poison the aquatic environment, which is a little bit of a nonsense because zinc oxide itself is a relatively stable chemical, but the zinc compounds we produce are water soluble and might interact then with the fish. But it's still a matter of concern. You know, you'll see a lot of suppliers talk about low zinc or zinc-free additives. We have our good friends in India also have that trend that is developed really right from that. But it's not the end of the story, and that's an ongoing, really, you know, really growing, if you like, or running issue. In terms of shelf life, you're right. That's another topic that you raised, and I think that shelf life, it's always an ongoing issue. Shelf life, when people review the shelf life, it only ever goes one way, shorter. Nobody says, oh, you can use or keep that chemical for longer. And people put that in as a kind of mandatory, let's say, protection. It's a very, I agree with you, sir, it's a very binary, black and white. So on day 364, it's okay. On day 366, it's not okay. That's not really a very convincing situation. What we try to do is to really inform our customers. We have an FAQ sheet for most of our products, which describes how to store the product, where to store the product, what kind of changes with time might occur with that product, what to look out for as a change with that product. We try to, again, holistically offer a service, if you like, where we can revalidate the product, because we understand that it's, in terms of cost efficiency, the product should not be disposed of on day 365, if you like. It should be used in a sensible and well-ordered way. But I fully agree with you that the storage of chemicals needs to be better understood, and the ways to handle those chemicals. I agree very much with Kishore. He commented about the better forms of the product, the special packaging that we can have, the suppression of dust and the better handling of products. For sure, these are absolutely things that we have to think about in terms of handling, dispersing, auto weigh handling. So again, removing the human exposure by having some kind of auto weigh handling, and special packaging and special forms of products are also really highly developed now, and a big area for future development in order to not only automate, but to improve or to mitigate the risks associated with exposure of chemicals. So I like that you present the challenges, and I like that, I see the industry very, very active in these fields, if you like, in the areas of trying to mitigate, if not solve, but at least to reduce the impact of these various issues. Yeah, if other colleagues would like to comment, I think that's really where we could set the scene for now.
Thank you, Colin. Samar? Yeah.
Yeah, the shelf life is very important for the chemicals which are like accelerators. Okay, and particularly the sulfonamide accelerator, CBS, NOBS, TBBS, and DCBS. And why these sulfonamides are critical? Because as Kishore had said earlier, this material break if they do not get the proper environment of storing, like humidity, high humidity, and high temperature breaks them, and MBTS formation or methanol insolubility arises. So here sulfonamide is the only rubber chemical which needs to be taken care. And antioxidants like TMQ, they may be used up to 1 year. 6 ppd TMQ are not having any problem. As such, you can go for 1 year. The rubbers like low or less unsaturated rubber, they can be used for longer time, maybe 5 years. Butyl EPDM, 5 years, no problem. Natural rubber, SBR, polybutadiene, this type of rubber you can use maybe the guideline maybe 2 years, maximum 2 years. Carbon black, no problem. Oil, no problem. Zinc oxide, no problem. Stable material have no issue in shelf life. Only the unstable material which transforms, for them the shelf life is more important. So here I want to say sulfonamide are critical. Kishore, can you add some more about the chemical?
Okay. Mr. Sundar, I think your question I have noted, and I'm basically from rubber chemical. So coming to the shelf life, I think what Doctor and Colin were talking about, among all that, only one family of the rubber chemical accelerator is the sulfonamides. Other products are not at all. I think you mentioned about some peptizole, that is a peptizer. It has a very good stability even for 2 years. Only what I will suggest that these bags, when you are using, you use fiber drum to again keeping the bag. Once you open the bag, then again tightening and handling will be there. Again moisture. So better I will suggest any rubber chemicals, whether it is accelerator or antioxidant, when you are using the bag for longer time, use fiber drum inside so that the contamination will be not there, less humidity, and the temperature effect will be there, because fiber drum gives the insulation property. So this is one suggestion. Then I think you mentioned about the normally sulfonamide, I will say, but practically no one is using. If you use air conditioned room, the sulfonamide can be stored for longer time, but practically it is not possible, I said. So sulfonamide, sometime, as you said, though the supplier gives the shelf life of 6 months to 1 year, depends upon the country to country, place to place, ambient temperature, humidity factor make lot of difference. So when the supplier gives, it is a very ideal condition, like the mileage, car mileage. When you talk about car mileage with the speed and road condition and all this, so here also that lot of factors are there. So my suggestion is that keep it in a good ventilated warehouse. Don't keep amines, antioxidant near to the sulfonamides, because it deteriorates faster. Then it should not be close to the boiler or heat, where so these are the small precaution you can take it and keep it in the 5 meter. Now, in spite of this also, the material is not being used for longer time. What will happen, right? So as Dr. Samar said, except sulfonamide, other products are quite stable for more than 1 year, sometimes 2 years also. So you don't have required to bother. Only you have to close properly so that contamination, moisture should not go. So that is why I suggested a 5 meter. Now, in case of sulfonamide, as you rightly said, you test on the small compound, right? So that is the best way to do that, because rheometer, just like your doctor checked your nadi and all this, Similarly, when you do the leometer, you get the idea about the shelf life of your product. Okay, so what will happen? Suppose I said the sulfonamide during the storage, high temperature and the humidity, it decomposes. So that is decomposed with MBTS and amine, and then Scotch safety will come down, which is very important for your compound because you are selling the compound. So you don't know when your customer will use the compound. So shelf life is important. So try to use the fresh product. But if you find that shelf life has come down, by adding extra retarder, your shelf life can be increased or your Scotch safety can be increased. That is the only I can say. This is not a solution, but as you said, from the economy point of view, there is no option. You have to use the old material, but please check it on the small compound, do the rheometer, and if you find the Scotch safety has come down, add more PVI, that is retarder, the Scotch safety will come down, and that can be used in your critical compound. So this is point of the shelf life. Dr. Edith, sorry, Samar, you want to add?
You rightly said. Here's one point that is giving some materials inside the bag, some small pouches. We can also take care.
Okay.
This we can take care.
Yeah, I think you mentioned about magnesium oxide. These are not because of the use, it is more from the technical point of view. Because these products, if it get exposed from humidity or moisture, their performance has come down. But in case of rubber chemical, practically it will not possible because normal packing is 20 kilo or 25 kilo pack. And I said these products, if you store properly, you can use up to 1 year, even 2 years also. But that can be added, but that can be done for 1 kilo packing and all this, but it will be additional cost for customer. Technically, if it is technically required, then it is must. But technically, it is not required. You can use it. Sulfonamide, I told you how to use it. If suppose it is old material, you can add PVI or retard a little bit, and you can match the Scotch safety.
Okay. Thank you very much, Kishore and Samar. I have when I had a discussion with Mr. E. Palinathan. Let me show you, my conversation with E. Palinathan, who also talked very good.
Can I interview?
No,
we have not answered his 2-3 questions. Let us finish up Mr. Sundar's 2 questions within just another 2 minutes. Can I do that?
Sure, go ahead. Sure. Yeah.
I think he mentioned about ROHS and REACH. Am I right, Mr. Sundar? Right. So as you said, for the small manufacturer, it is not possible to test their product. So I will advise the major supplier, you can request them to give the declaration and the certificate for ROHS and REACH, which is at least for rubber chemical we are doing. And that certificate itself, suppose your major products, I'm talking chemical, rubber, synthetic rubber, natural rubber, it is not required. It is majorly basically for the chemicals, and suppliers give you certificate because every supplier will not have a REACH certificate, but he can test the chemicals which is there in the European REACH every year, and we test that chemicals and we give the certificate that these chemicals what we are supplying, it is within the ROHS and the REACH certificate, and these are I think every year they renew it. And if your major suppliers are giving certificate, you can declare that your product is free of ROHS. Am I right, Dr. Samar?
Yeah, correct. Colin, what is your suggestion? Is it okay?
It's absolutely okay. Yes, of course, to control ROHS and REACH. ROHS is mostly done by, of course, the leading suppliers, the leading producers. They know very well that, or they send their chemicals to third-party laboratories for testing, and they get the certificates. We control ROHS very well. We understand that. We understand PAH legislation for certain aromatic materials, let's say for resins and these kind of products. We understand the SVHC, so the substance of very high concern, the toxic chemicals. But of course, this is very difficult to test individually for every rubber producer, and they want to have the security that the rubber compound they produce is also free from ROHS or SVHC free. So you can ask that, of course, you can insist on that from your supplier, and the suppliers, as the gentlemen have said, will do that, can do that. They have REACH registration or they have access to the database to confirm that. This is, of course, always a good thing. So everybody is sharing more and more information. Even if it's a kind of proprietary chemical where people say, it's very difficult, it's a kind of innovative mixture or an advanced chemical, I cannot say so much about it. There are mechanisms like the IMDS, the International Material Database System, where the supplier can share information to the user confidentially and in a secure way. So there are many, many channels and many ways to share information and to build up the confidence level that you as a producer have safe chemicals in use. And if you're working and everybody wants to work with, and we have on board here responsible and reliable producers, I would say, you will get that level of support if you reach out to your suppliers for that. It's sometimes difficult to interpret that, but of course this is the job of the supplier to give you the guarantee and provide the information that you can be sure that what you have is a safe chemical. That might change, of course, as we say, as Kishore mentioned, that gets reviewed very, very periodically, maybe annually. So it's always good to re-update the situation. What you have this year might not be in the same classification next year because the regulations change. But in general, that's really a good situation, I would say, for everybody. So yes, that's really what I could say on the topic. I hope that's of help to you.
Okay, there's the carcinogenic issues of the database.
Yeah. Anyone to talk, or I can talk?
Yeah.
Continue.
Okay, go ahead, Kishore. Go ahead, Kishore. Yeah.
Yeah. I think, Sundar, you have rightly pointed out that the carcinogenic issue is how far it is reliable, whether it is really there, or there is authenticity is there. These are a lot of questions come. I think this nitrosamine issue is there for last 30-40 years, frankly speaking, because I am with this industry for that. But as you rightly said, the replacement of these products are not easy because you require new chemicals, you require a new chemistry. As I said, normally when you add, it is on molecular basis. When new molecule is a higher molecular weight, then your dosage will be increasing. So as I said, I think you mentioned about TMTD and TBZTD. So as such, if you are using 1 pHR of TMTD, maybe to get the same pure characteristic, you may require 2 pHR of TBZTD. Then the consumption of TBZ is very, very less. Suppliers are less. Raw materials are also very costly. The price also is high. So that is the reason why when the replacement from TMTD to all, you required some time. Maybe we can help you to, I'm not saying the entire, but cost reduction can be done. But as you said, anything new, it is costly. Then coming to the nitrosamine, what happened, I have seen in the tire industry also, I think before 1990, when they started about talking thing. Normally what they do, when any old design, if they are using any nitrosamine product like MBS and TMTD, so they don't change the design. So they don't change the formulation. So they wait up to that design it getting obsolete. Any new design come, they will be coming with the product which are safe, nitrosamine free and all this. Am I right, Samar?
Correct, sir.
Correct. So this helps also the cost. So slowly depends upon the local legal requirement or his customers. His tire customers are basically Ford and depends upon that. And whether exporting, the rules are different. Again, Europe rules are different. So depends upon that, they select the product. Okay, in products going in Europe, they will not use this product. The product going in this product, they will not use it. Maybe in some product they will use it, and slowly they will phase out. So nitrosamine issue was there. Now it is becoming more severe. People are asking for the declaration where these products are not being in use of product. So depends upon your product, customers, country. You have to see that what type of product you are going to replace. So this nitrosamine issue, it is a official body of European Chemical Agency. They have declared the products which are already carcinogenic. Like I told you, MBS in the sulfonamide, TMTD and all this. But there are some products on the borderline. They are on the borderline for last 10 years. One product I will tell you about it is DCBS. But what they do, they will allow you to reduce the content. But they are not yet banned. They are not converted to this completely carcinogenic. But they says it is on borderline, still in the question mark. Because unless they get data and again they prove it is 100% carcinogenic, they don't ban it. So there is a process to do that. So these products are like another product is DPG. These are on the borderline. Still it is borderline. So whether the product borderline you want to use it or not, that is different. But there is an official body which declare that this product is nitrosamine free or not nitrosamine, because it is depends upon the chemical. The data is available, PPH level, ppm level. It is not that anyone can say that, oh, my product is nitrosamine free. No, these are basically chemical product, not the brand name. Am I right, Colin? Okay, thank you.
Yeah, absolutely. You're right. Yes, yes. So it depends on the chemical, not on the brand name. So, and with many of these chemicals, accelerators, anti-degradants, they are very defined chemicals. So you can easily look up what is the chemical name, what is the structure of that, and you'll know whether it's carcinogenic, not carcinogenic, or as Kishore says, what's the very challenging issue, falls into the grey zone. Maybe yes, maybe no. It depends on the testing or the state of the interpretation of that testing. And this is the real challenging area, I would say, with some of these chemicals, to understand what you can be and then whether you want to mitigate against that or not. But you will know whether it's safe or not safe, and which kind of actions then you need to take with these defined chemicals. Of course, this is really, at least for the European situation, very clear now.
Okay. Thank you, Colin. Thank you, Kishore and Dr. Samar. Sundar, I'd like to show you the recorded version of my conversation with Mr. E. Parinathan about his point of view on the rubber chemical quality, because he's been involved in the manufacturing side. Let's have a the view on the Mr. E. Parinathan. Please stand by. It will be around 15 minutes talk. Okay, so hi there, EP. Welcome to the rubber industry panel discussion. Thank you for joining this session. Today we are talking about the rubber chemicals quality and handling. That is one of the topic, a very important topic for the industry to understand about the rubber chemicals. As you know, you are a specialist in compounding, molding, work with industry for more than 30+ years, and I'm sure that you have seen number of interesting issues related with the rubber chemicals. Particularly, you may have received so many chemicals from the different suppliers, okay, and also variety of quality issues, and also how you store them, and maybe your staff handling them. There are issues storing. You may have a practice about you may say I have 5S in place, I have ISO 9000 in place, everything in place, but it's also down to your supervisors or your floor people taking care of this, these chemicals. So let's hit the ground with what is your experience, with the rubber chemicals?
In a rubber industry, especially a non-tire industry, the raw material plays a very important role, actually. So it is the base on which the product is built on. So one has to do a focus on this. So we can classify the issue of raw material by way of by 4 characteristics. One is the specifications. How do you specify the raw material specification? That's the first starting point of the whole raw material gamut. So where in any rubber chemical, you have to consider both the chemical, the chemistry, and as well as the physics or physical nature of the raw materials. So the specification should be clear cut. That's the first starting point of any raw materials. There one has to be very clear what is the requirement for what we are going for this raw materials. So, and next, not only the physical and chemical, we also have to focus on the packing. Packing also is very important, and the identification, and how do we get the traceability of the material. So all these things are very important when we go for any raw material. Next, once you specify these characteristics, we are going to get materials from supplier. The next is to establish the quality. The most important thing is how do you sample? What's your sampling plan? Who is going to sample? So here in the industry, normally they take an easy route of just sampling, ask the stores person to take some sample and give it back to laboratory, which is quite a wrong practice. No, one has to take some pain, especially from the laboratory. People has to go and see the bag, and then they should draw the sample. So sample should be an independent sample. So then he has got a choice to take the sample from any bag, wherever it is. So that way, the sample represents the true characteristics of the lot. That's the one thing what I want to insist for the industries. Then apart from that, the test report. The next is the test report which come along with the raw material. Many times we see the test report supplied by the dealer. The dealer will put his name, letterhead, put the data and sign and do the report. We should have a practice of insisting a test certificate generated by the manufacturer. The manufacturer quality department is a person who is genuinely authorized, who knows about the chemistry of the test report. So I suggest most of the, especially small and medium scale manufacturers, to insist on the manufacturer test certificate. This may be it may be addressed, it may not be addressed to the actual customer, it may be addressed to a dealer. It doesn't matter. So that you get a correlation between what is there in the lot number mentioned in the bag and what is mentioned in the test certificate. So that you know what is the quality of the material you are receiving it. And also you get to know clearly what is the date of manufacturing. So from the date of manufacture, you know very well there is every raw material has got some shelf life or expiry. So we can track the expiry unless you get a clear test report. Okay. So once you have a good specification, good sampling, good test certificate from the vendor, it's always a practice to have a test certificate verified. If not, there's about 10 properties mentioned in the specification. At least some few properties should be confirmed with the every consignment. So they'll give a COA, that is analysis report, that has to be confirmed. And also you can have a sampling plan. Many times when establishing any new raw materials or alternate materials, we always test too many parameters. So most of the time the testing is at times thought as a non-value-added process. Obviously, because we are testing and saying okay. If it is okay, where is the value addition? So it is always thought it is not a big value addition. But still, we should do a minimum number of testing. At least test report validation. Test report you should take and then verify. And test one or two basic properties. I recommend, for example, say for every raw materials, we have got some parameters. For example, for chemistry, you want to check, you can have one small FTIR. Nowadays, FTIR is very cheap and it's available at a very low cost. You can buy an FTIR spectrometer. Just like that, we can check, see the chemistry of it, and we can check the bulk density to know the particle size, that is physics of the material. The specific gravity, which shows what is the chemistry. For example, the specific gravity of zinc oxide is much higher than the other minerals. So same way, the one melting point. These are all the basic tests if you can do at least at random. So you get to know about what kind of raw material you are getting it across. So raw material, some part of testing is important, and the test report validation is also important. This can be correlated with the compound test results. In fact, if you cannot do a much detailed test analysis of raw material, it is better to run a trial batch. You will get a consignment, make only one change, only one particular chemical you are going to buy, that get changed, remaining same. Then you can run a rheograph and then compare versus the one which you are running the standard material or one with running with the new material, new lot that has come. Once you compare these two, you get to understand many things. Is there any significant change because of the change of a raw material lot change? This is a practice being done by some of the medium scale companies, by which they are sure. But any change of the lot of the raw materials, because as you know, the compound consists of more than 10-15 raw materials. So when you change the raw materials, you make sure that it is not shifting the rubber property, the compound properties. Yeah, that's a good practice. And also the compound density, also a very important parameter. I got an experience because there are fillers. There are two types of fillers. We have used some silica filler with 98% silica and a silica filler with about 80% silica. Both are having the same trade name, but only the number, the adjacent number will vary. One will be 2 219, another will be 209. So in regularly when the people get the bulk consignment, the dealers will do a repacking to preserve the packing. So when they do repacking, there is always a chance that they'll put a wrong numbering. The 209 inside material, they'll put outside 219. It get invoiced also as the 219. When we see, this is what happened. When we made the compound, the density was totally different. As you know, the silica content decides the density of the compound. In the compound density was different and the rio was different. So we have to track back, even though the material is same. Again, we have to doubt on this material. Again, repeat it again. So we can't simply go to the raw material supplier who are all giants and say that your material is bad. So we have to reconfirm twice, and then take up with them. Finally, we've seen, yes, there is some issue has happened by way of identification. So the identification of the raw material is very, very important. It's what my message to the raw materials. And the last but not the least, the storage is also very important. Many times we have to see the chemistry of the materials while storing. For example, here we have mentioned about rubber chemicals. There are some chemicals which are prone to degrade with little high temperature storage. So we have to identify them, especially for example, if you are taking a polychlorinated rubber, it used to crystallize and then the viscosity will increase. So we have to necessarily store in a very low, a very little lower temperature to preserve the viscosity. So that we should have an understanding about the material behavior on storage. That's very important. Accordingly, we must assign the material in the particular, is it an ambient condition or it is in the air conditioned storage. Along with that, we should know about the severity of the fire hazard also. Something like a sulfur, you can't keep the sulfur along with other chemicals. Even though there is a government regulation that sulfur has to be stored separately, there is a separate regulation is there. Some small companies, they have to take a precaution measure on this, because medium scale companies, yes, they have got a separate sulfur godown will be there. They're used to follow that. Small companies, they are also using a lot of sulfur, but they have to take a self precaution, especially the SMSC, the small and medium scale companies. So this is one thing. And next is identification when we give small quantity from a large quantity. So the many companies nowadays, they use a they put a barcode. Whenever you do a repacking, I suggest to take a barcode, put the barcode, whatever barcode is there in the main package, that should carry forward in the secondary package also. That's very, very important, because we cannot identify the material in a factory by way of color or powder. When it is white, everything will be white, silica will be white, all fillers will be white in color. So the color identification is not alone dependent. We should not totally depend on color or weight. So we have to do a barcode. Recently, people have come out with the barcodes so that there is no confusion of wrong chemicals getting added. So because these things can happen in the mixing plant because of the lighting, because of the work pressure. So we should make a okay, so that there is no wrong chemical being used for any formulations. That's what I think some of the good practices one should follow. I think it may add some value to your thinking process. Anything further? Probably the next program we will continue.
Yeah, I'd like to add some additional points, for the discussion. You have mentioned that sometimes the repacking, the dealer repack, they may buy in the bulk and repack in issues, and you mentioned that your compound got in trouble, okay, and what kind of corrective actions you take back? Your compound got destroyed and you had to redo it again, or you get compensation from what kind of arrangement usually?
No, really, because we don't allow large material to be rejected, because we've got a quality system. The system will catch. We may make one big batch, about maybe some 10 kg or 12 kg of material loss is there, and we take up with the supplier, depending on our supplier relationship with respect to how much percentage this volume contribute to the total. For a medium scale company, this will not be a much higher economic impact. So to keep the relationship, we will scrap from our end. That's what I think, because most of the chemicals are all single source material, and since we are identified at the beginning stage, since any company has got a good quality system, they can identify in the first batch itself. If you don't have a quality system, it will pass on up to the product. Then it's going to be very severe. So if we pass on the wrong material into a system, we also become responsible for using a wrong material. So we must take the ownership. We can't push it on the raw material supplier.
That's true. That's true. And when you open the bag, you may not use completely for the certain batch,
Yeah,
right?
right.
This is
We have
also
to repack. We have to reseal it. We have to seal it again with the proper stickers and close it again. Close it again.
Yeah.
And in fact, we will identify that bag as a sampled bag like that. So that bag will be first issued. So that it is since it's open bag, that bag will be first issued for production. That also a good practice.
and also it's something with the coding, the expiry date also very important to be highlighted. Is it right?
Correct. Correct.
Yeah.
So to have the expiry date tracked up, we should have a FIFO, first in first out system. And we should nowadays there are tracking mechanisms. Whenever you issue one particular lot, the lot will move along with the expiry dates. So whenever you shoot from stores, it will go with the scanning. Once you go, and at the next stage also, we will know what is the expiry of this material. Accordingly, it will move forward. So unless you not to have an expiry product, raw material, we should strictly follow FIFO. Practice FIFO. Not only for document, we should practice FIFO. That's my.
There is some interruption. Sorry about that. I will show you that one later on. Okay. Just a second. Okay. In the meantime, let me invite Mr. Salut. He is the business development manager for the Sunny World Chemicals. He's one of the leading Sunny World company is one of the leading rubber chemical suppliers in Thailand. I want to know his experience about supplying chemicals to the rubber industry in Thailand. You're supplying to the both tire and non-tire industry. Kun Salut, please.
Hi, Mr. Baram. Thank you for the introduction. As mentioned by you, our company, Sunny World Chemicals, we have been in the business of distributing of rubber chemicals for almost 40 years. Our customers are ranging from big to small companies, including multinational and local ones. So basically, we have been handling all kinds of rubber chemicals. There are a lot of variety on requirements, standard, and also practices in order to achieve good quality and consistent products. Based on our experience and opinion, we have some points which we would like to share on how to ensure that quality of the products that our customer receive is in good and best possible conditions, suitable and fit for their use. First of all, as number one, we as a trader, we rely heavily a lot on the makers. The reputation and also good manufacturing practice system of the manufacturer. Initially, we screen and select products for our customers based on the makers with good standard and reliability, based on our knowledge from the market research, checking and inspection. We always provide the products in original bags of the manufacturer. We don't do repacking at all. Yeah, this is in order to avoid contamination or oxidation of the material. This is our principle. So the customers can be confident that what they receive is the original from the makers. Number two, the inspection of incoming materials. The goods are always carefully checked that they are in good conditions. There is no damage, leakage, or broken bags or broken packaging. This is so important because this will impact the quality of the product inside. Yes. For the case of magnesium oxide, for example, we used to receive a broken bag, believe it or not, because of the moisture absorption. Within 2 weeks after our reception, the bag size is about double size of the original bag. So we can tell immediately that this is not good to be used. Also, handling is very important. Loading and unloading procedure in proper way is a must. So we have to carefully manage it, do it in a good practice. And also, Mr. Kisher already touched on this topic as well, the storage. We are in Thailand, we are based in Thailand, so we are in the country where the temperature and humidity is at a high level. So by keeping the products in proper conditions to ensure that our warehouse have enough ventilation, and also we must keep the products away from direct sunlight or hot area that will impact the quality of the chemicals. For some items which are very, very sensitive to the moisture and the heat, we also have the cold storage, air conditioned room with the moisture control equipment. This is highly recommended for some very sensitive chemicals to the moisture and also the heat. Of course, we always work and discuss closely with the makers of the product. Okay, and sometimes I would like to mention when we receive the products which is made in the cold country, after receiving and open the container, we found some condensation inside the container. This is due to the long transit time in the ocean. So when we receive it, we need to unwrap it and let it dry for quite some time to allow the moisture and also the condensation to evaporate. Packaging of the bag on material is also important to prevent the moisture. For example, the PE bags or bags with plastic lining is very helpful to prevent the moisture to get inside the chemicals. In some cases, we encourage the manufacturer to put enough desiccants inside the container to absorb the moisture during the ocean transit time. And for some chemicals, we have to keep in separate area because we want to prevent it from chemical reaction, as mentioned earlier. And because of the dusty nature or to keep the contamination from this kind of chemicals to the other chemicals. Number 4, Mr. Sanda also mentioned earlier as well, the fresh materials. This is always our main focus. As we know, in general, the fresher, the better the quality. The FIFO system must be in place. We make sure that there is no backward lot received from the maker. The inventory must not over the shelf life. And we would like to get the fast movement material. And the most important is the requirement from the customers. We work closely with the customer to set the standard to ensure the good quality of the products. For instance, the test report, we always provide the original certificate from the manufacturer to the customer. And if some testing is required, we send the chemicals to the third-party lab, such as SCH, SGS, to do the testing to validate the result. And the sample of chip lot are tested to make sure that some properties that are important to the production, health, and also safety application are within the spec. Some customer, they require special type of chemicals, like for instance, in the pellet form or in the mass batch form. This is in order to keep good and healthy environment in their production facilities. And some very strict customer, they also required that the product that we deliver, we must put in plastic pallet only. They do not accept wooden pallet at all. This is not acceptable in order to prevent the FM, foreign material, to go inside their compound. This is the small things that we learn from the customer and should be something that we have to address carefully. Most of the time, we also found the problem of accumulation. I think you also regularly find it. It can happen. This is involved with the discussion with the manufacturer as well. We need to set up the certain level of melting point, as mentioned earlier, and also to adjust the proper hardness of the material to ensure that the dispersion is there, but there is also a good processability of the product. accumulation is a big headache to most of our customers to handle and use them in their compounding. And also stacking level of the bags or box can help in this matter. We found that sometimes putting the products inside the boxes are easier, are more effective to keep the accumulation away from our inventory. Okay, this is the practice that we would like to share and encourage most of the customers to do it.
Thank you, Sunsal. You really put it nice way in point by point, the practice, good practices that you're implementing at Sunny World. Thank you very much. May I ask Mr. Hamid, to come forward, you share your experience. You are a manufacturer of tires, one of the leading manufacturer of the tires in Pakistan, and you are responsible for the compounding. So you must be handling all the chemicals involved, so dealing with it. So can you talk about your experience?
Hello, everyone. So today we are here to talk about the handling and storage of chemicals, basically. So I would like to share some of my experiences about it. So one of our panelists, I think his name was, I have to see it from the panelist list. Mr. Kishore, I think Mr. Kishore mentioned it. One of my points, he already mentioned it, but I'll continue it further regarding the sulfonamide accelerators. And another point is regarding the insoluble sulfur. For these two materials, I have decided to discuss today. One was the sulfonamide accelerator. I intended to discuss it later at second stage. First, I wanted to discuss insoluble sulfur, but since a lot has already been talked about the sulfonamide accelerators, so I would like to start from this particular material. The sulfonamide accelerator, we all know these are widely used in rubber compounding, definitely for the accelerating purpose of the Cure reaction. And we all know these include 4 or 5 materials like CBS, MBS, TBBS, DCBS. So as already discussed by Mr. Kishore, these are susceptible to degradation if exposed to humidity. So continuing his discussion, this I think you all can see on your computer screens, a sort of chemical reaction for that attack by the humidity on the sulfonamide accelerator. The general structure of the sulfonamide accelerators is shown on the left of the chemical equation, and when they are exposed to humidity, which is ultimately the water contents, moisture, we can call it moisture, we can call it water content, we can call it humidity. The part of the sulfonamide accelerator is converted to MBTS. MBTS, although is also an accelerator, but it belongs to another category of the accelerator, which is thiazole. So MBTS, as most of us know, is comparatively fast curing as compared to the sulfonamides. So if sulfonamides are exposed to humidity, part of it gets converted into MBTS, which ultimately is an accelerator, but not desirable with sulfonamide because it reduces your scotch safety. And another side product is free amine. This also affects the, you can say, the activity of the sulfonamide accelerator and ultimately affects your scotch safety, which goes down, and then you may face problems in the processing like calendaring, like extrusion, and so on. And it has also been discussed that with the degraded sulfonamide accelerator, we can still use it. Definitely, we can still use it. We cannot discard it. We cannot write it off due to economical reasons, economy reasons. So we can ultimately opt to add some Scotch inhibitors, which is PVI. I mean, there are a lot of tricks to use it afterwards, after it has been degraded to some extent. But to the continuity of the discussion of Mr. Kishore, this is basically the chemical equation for that degradation caused by the humidity. So this was one of the points I wanted to discuss. And another point is regarding the insoluble sulfur. Sulfur is widely used vulcanization agent for the rubber compounds. There are basically two forms. One is a soluble, another one is insoluble. Definitely we use insoluble sulfur to avoid the issues of blooming and the subsequent consequences of the blooming issues, like loss of the adhesion between the multi-layered components of the rubber compound. So in order to avoid the blooming issues, we opt to use insoluble form of sulfur instead of its soluble form. But using the insoluble sulfur itself is very critical. I mean, you just can't say that I'm using insoluble sulfur, so I'll not face the blooming issues in my product. No, this is not the case. You will still face the blooming issues if you're using insoluble sulfur in an incorrect way, or if you're not giving due respect to the insoluble sulfur in terms of its storage and handling. Insoluble sulfur, not only the storage conditions, but its handling and temperature control is also very critical. Temperature control not only during the storage but during the processing as well. Like if a temperature goes beyond a certain limit, insoluble sulfur, it gets converted into the soluble form and ultimately causes the blooming issue. We intended to use insoluble sulfur just to avoid the blooming issues, but it got converted to soluble form due to storage condition, due to mishandling, due to temperature issues, and ultimately we have to face the blooming issue despite using the insoluble sulfur. So it's storage as well as handling. Both these parameters are very important. Pam, can you please show slide number 13 here?
Okay, please stand by.
Yeah, this one. This particular slide is all about the storage conditions. Like if the storage temperature is 50 degrees Celsius and within 1 week, almost 10% of the insoluble sulfur, it gets converted into soluble form. I mean, you have already lost 10% of its effectiveness if you store it just for 1 week at around 50 degrees Celsius temperature. So this particular data I wanted to show just to highlight the importance of storage temperature while using the insoluble sulfur. Now I'm coming back to slide number 11. Yeah. Okay, here, what does this slide show? This slide shows the solubility of sulfur in various elastomers at different temperatures. Even the soluble sulfur, the one we call the soluble sulfur, which ultimately causes the blooming issues, that is not, even that is not totally soluble in the elastomer. That is only a few percent soluble in the elastomer, but those few percentages, even those cause the blooming issues. So this graph, this shows the solubility percentage of the soluble form, not the insoluble. I'm talking about at this point of time, soluble sulfur. This particular slide shows the solubility criteria of the soluble form of sulfur in various elastomers at different temperatures. One trend is common in all these lines is that as the temperature increases, the solubility limit of the soluble sulfur in various elastomers, it increases. Although the trend is different, in some elastomers, the solubility limit is lesser, in other elastomers, the solubility limit is greater, but the trend is same. As the temperature is increased, the solubility percentage in all these elastomers, it increases. So why I wanted to show this slide? I wanted to show this slide because at around 105 degrees Celsius, that is considered to be the critical temperature during the processing of the compounds containing insoluble sulfur. The 105 degrees Celsius temperature is generally considered the critical temperature during the processing of rubber compounds, where the insoluble sulfur gets converted into the soluble form. So like I'm from the tire manufacturing, we have to calender the rubber compound, we have to extrude the rubber compound, we have to strain the rubber compound before giving it the final shape of a tire. So during those intermediate processing steps, the temperature goes like from 100 degrees Celsius to 120 degrees Celsius. So if we are using insoluble sulfur, we not only need to maintain the proper storage conditions in terms of temperature, but we also need to be careful in terms of temperature when we are extruding any rubber compound, when we are doing the processing at calendering of any rubber compound which contains insoluble sulfur, because as the temperature will increase during the semi-finished steps, during the intermediate steps, the more and more of the insoluble sulfur will get converted into the soluble form, because the solubility limit will increase. Not only the solubility limit will increase, but the conversion of insoluble form into the soluble form, it will also speed up. Another data I have collected regarding the insoluble sulfur. Pam, can you please show slide number 16 here? Yeah, this one. On one side of the slide is a graphical representation. On the other side of the slide is a table depicting what other ingredients have we used with the insoluble sulfur. And let me tell you one thing before giving the briefing on this particular slide. The table you are seeing, like at serial number 2, you see insoluble sulfur with TBBS. TBBS, one of the sulfonamide accelerators. Insoluble sulfur with TBBS having around 96.5% purity. So this particular combination of insoluble sulfur and 96.5% pure TBBS, this is not in the rubber compound. Just the insoluble sulfur and TBBS, these two are individually mixed together. You can say in their raw form, in their virgin form, be it in the granular form like TBBS, it can be available in granular form, in powder form. Insoluble sulfur mostly available in powder form. So just to make my point clear, we take the example of the combination at serial number 2, insoluble sulfur with 96.5% purity TBBS. These two ingredients are individually mixed together. Okay, and then these are kept for a number of days at 50 degrees Celsius temperature, just to see how these different ingredients affect the conversion of insoluble sulfur into soluble form. So if we see the combination number 1, which is the insoluble sulfur alone, without the admixture of any other ingredient with it. So you can see specimen of pure insoluble sulfur, it shows negligible loss when aged at 50 degrees Celsius for around 1 week. I showed it in another slide, like at 50 degrees Celsius for 1 week, it lost around 10% of its effectiveness. For the serial number 2, the combination is insoluble sulfur with TBBS in 2:1. Insoluble sulfur 2 parts, TBBS having 96.5% purity 1 part. So we can see in the graphical line, the line representing the serial number 2, it fell sharply. Insoluble sulfur blended with TBBS having 96% purity shows a loss. This loss is around 30%. So it means 30% of insoluble sulfur it has converted into soluble form just in a week if kept in contact with TBBS accelerator, sulfonamide accelerator. What does this signify? It signifies that during our storage conditions, during our warehouse storage, we should avoid keeping insoluble sulfur and TBBS in the close vicinity, because ultimately the TBBS and insoluble sulfur from the environment, they will interact with each other and ultimately will cause the degradation of insoluble sulfur. Now, coming to serial number 3, you can see the TBBS, the same sulfonamide accelerator, is in contact with insoluble sulfur. But this time, this particular sulfonamide accelerator has already exposed to humidity, as we discussed in a short while ago, and Mr. Kishore has given a lengthy briefing about it. TBBS accelerator already exposed to humidity, already degraded. We also saw the chemical equation for this a short while ago. Earlier, the TBBS was 96% pure. Now it has lost its efficiency to 77%. And you can see the line in the graph representing serial number 3. It has fallen most sharply over here. So the insoluble sulfur blended with degraded TBBS, which has already exposed to humidity and has undergone the degradation, it is the most detrimental, the most dangerous, as it showed a degradation of around, I think, 85 to 90% in just approximately 3 days time, as we can see from the line in the graph representing serial number 3. So what does this signify? It signifies that TBBS accelerator definitely affects the conversion of insoluble sulfur to soluble form. But if that particular TBBS accelerator has already exposed to humidity and has already got degraded, it will affect the conversion of insoluble sulfur to its soluble form even more rapidly. Now the next point is insoluble sulfur with same as serial number 2, 96.5% purity, but this time a PVI, the Scotch inhibitor, is added to it, just to see see whether this Scotch inhibitor PVI, it stops TBBS from degrading the insoluble sulfur. So from the graph line representing serial number 4, you can see it's almost a straight line. The whole of the insoluble sulfur contents are retained even after 1 week at around 50 degrees Celsius storage temperature. So this means the PVI, the Scotch inhibitor, it has the power to prevent TBBS from destabilizing the insoluble sulfur and stopping its conversion into the soluble form. Now coming to the serial number 5, it is same as serial number 3, but this time an acidic content is added in the ratio of 1 part, just to see whether the acidic content, it has the ability to neutralize the amine content liberated by the sulfonamide accelerator, which ultimately degrades the insoluble sulfur. So if we consider this serial number 5 curve, so we can easily conclude that even the acidic content, that has no power to neutralize the amine content liberated by the degraded sulfonamide accelerator, which ultimately causes the reversion of insoluble sulfur into its soluble counterpart. And the next combination is the insoluble sulfur with HMT, the hexamethyl tetraamine. So this blend of insoluble sulfur with HMT shows the same detrimental behavior, the same degradation of properties as with the degraded TBBS, like we saw in serial number 3. So the lines of serial number 3 and serial number 5, you can see these are almost, similar in terms of degrading the insoluble sulfur into soluble counterpart. And another one, insoluble sulfur with MBT. MBT is another accelerator, but this is a non-amine based accelerator. It does not creates the amine content as the byproducts during its degradation. So as we know, the TBBS, as it is exposed to humidity, it liberates the amine content. But MBT, which is also an accelerator from the thiazole category, it does not liberate the amine content as it degrades. But for the serial number 7, we can see that the insoluble sulfur and MBT, the combination, it clearly demonstrates that MBT does not have any adverse effect on insoluble sulfur. As we can see, the line representing serial number 7. So what does this signify? It signifies that TBBS, which is a sulfonamide accelerator, as it gets degraded, it liberates the amine content. So it ultimately degrades the insoluble sulfur. But MBT, which is also an accelerator, but it belongs to the thiazole category of accelerators, it does not liberate amines as a byproduct as it degrades. So since it does not liberate the amine content, so it will not have any adverse effect on insoluble sulfur. It will not have any degrading effect on insoluble sulfur and will not cause its reversion into the soluble counterpart. Now one question arises, like as I told you at the start of my briefing of this particular slide, that for example at serial number 2, the insoluble sulfur with TBBS, these two ingredients are not present for this particular study. These two ingredients are not present in the rubber compound. These two ingredients are blended individually with each other. Now one question may arise, it arises in my mind, maybe some of you already know the answer, but it arose in my mind. Then I did my research and found its answer. When these two materials, these two ingredients are present in the rubber compound, like which contains the fillers, the antioxidants, anti-degradants, the oils, the elastomers, so will they give the same behavior in the rubber compound? Like if I design a rubber compound which includes the insoluble sulfur with TBBS, so it means the TBBS present in the rubber compound will ultimately start degrading the insoluble sulfur during the storage of the rubber compound, but it does not happen like this, because in case of the blended rubber compound, there are a number of partitioning agents between the TBBS and insoluble sulfur. These partitioning agents are the fillers, the plasticizers, the elastomer itself, and a lot of other compounding ingredients we use with it. So those compounding ingredients, those are the kind of partitioning agents between the TBBS and insoluble sulfur. And when these two are present in the rubber compound, so such kind of degradation of insoluble sulfur into soluble form will not happen. So this was all about from my side, from my experience, from my study. So this was all about from my side. Any question or any discussion, let's do it.
Thank you, Hamid. Thank you very much for your excellent input on the insoluble sulfur. Dr. Samar, you want to add any point on this?
So what Hamid has said, it is very correct. And not only TBBS, any sulfonamide accelerator storage with insoluble sulfur will be detrimental. So insoluble sulfur cannot be stored adjacent to sulfonamide accelerator. Any sulfonamide, CBS, TBBS, NOBS or DCBS, all will have the similar effect.
Thank you, Dr. Samar. Yes, I have one more speaker, Mr. Bharat Sharma. I had a conversation with him about various issues about rubber chemical quality and handling. Let me show you the video of my conversation with Mr. Bharat Sharma. It may take around 15 minutes also. Okay. I know the session is long, a lot of interesting issues, so please stand by. Namaste, Mr. Bharat Sharma ji. Welcome to the Rubber Industry News Hour. Thank you for taking the time to join this panel discussion on the rubber chemicals, quality, and handling. Okay, welcome to this session.
Thank you, Param. I would also like to thank for inviting me to this particular forum and taking my opinion on this subject. Go ahead.
Yeah. So let's dive into the the key issues what we discussed. Before I get into the chemical aspects, you are currently a president of the Corporate Technical Services for the TWC Group, and which is one-stop solution for the specialized rubber chemicals. Can you talk about, briefly introduce about the product line, please?
Yeah, TWC Chemicals or TWC Group has got two sister companies. One is Technovex Chem. They got two plants in Calcutta and one plant at Baroda, which is Rasha Chemicals. They make specialized chemical and with a kind of objective of going ahead and doing the import substitution, which are kind of valuable customers are looking for. So we keep on developing new chemicals which are special and being used by our major customers, which are tire industries, for their special requirement, which typically no one is producing. So we've got a specialized line like bonding chemicals, which are Resorcinol, HMMM, and their dispersion, HMT dispersions. HMMM, practically, we are the only one making HMMM here and making HMM dispersions as well. We also make specialized resins, which are now alpha methyl styrene resins for high performance tires. We make phenolic resins, which are kind of SP1068 equivalent. We are second in the world to make a special resin called co-resin, having superior or supermost stack for rubber compounds. We also have process aids, various process aids and homogenizers required by tire industries. We also have kind of customer-friendly wood rosins converted from wood rosin into pastel form, which people find it comfortable. We also have kind of gum rosins and various dispersions, and we supply all across the world, and our volumes are going to be almost about 500 crores this year, and we target to achieve almost about 1,000 crore in 2025. We have good expansion going on, and volumes are almost 50,000 tons, which is going to increase to about 100,000 tons by 2025. We have expansion plan in place, and we are being working on a special projects with joint venture with companies, and we've been recognized by many major companies as a valuable development partner and research oriented people or technical savvy organizations. So that's a kind of big short info. It's a private company led by Sushil Agrawal and his two sons, which is Abhishek Agrawal and Ashish Agrawal. I think
Excellent.
That should be good enough.
Yeah, that's excellent. I think you should have a long list of product line, and I can see that, understand that you supply to the major tire companies. So quality of your chemicals is very important for the
I missed one subject, which is wax. We also make specialized waxes meeting all requirement. Okay.
Sure. Okay.
Yeah.
So can you talk about you are, as you mentioned, that you supply to the various tire companies locally and internationally.
Mhm.
What are the what are the quality management systems that you implement in your company before you supply to the deliver to the clients?
See, Param, like I've got a very special or atypical exposure. I started while working for tire industries, 3 tire industries in India, having collaborations across multinational companies, and then moved to the other side of the world, which is rubber, which is supplying to the tire industry. So I was kind of aware about the requirements, what customers are looking for, because I've been hardcore rubber compounder and
Yes.
lab person. So basically, I was expecting that when we joined this company, TWC, what customers are looking for, I was very well prepared. So whenever we kind of give the samples to customer, we ensure that what is customer looking for. So we do have a rubber application center also, which takes care of testing and simulating customers' expectations before we approach the customers. So kind of a development activity. Yes, homologation with the tire majors is really a big challenge, but we are lucky that our clientele list includes most of the multinational companies, and we are now expanding our focus on non-tire customers as well. But yes, our clientele list is pretty good. We supply to almost 35 countries, and obviously in India as well. So we are kind of approved by many people.
And I did get the point that that's well everything in systematic way that you implement. Can you highlight for the benefit of the audience? What are the things that you suppose I'm the customer, I'm wanted to buy some chemical from you, and what kind of management systems that you submit to us and provide us, whether it is certifications or on the
Okay.
test results and things like that. Yeah.
So I'll try to give you 2-3 points. One is, okay, when we go about development of materials, we go take the samples, we take counter samples, we do the specification review, we see the capabilities of whether we can develop such similar systems or similar chemicals here, and we keep on interacting with the customer. We are under technical secrecy agreement. So that is one. Once we develop, then we supply them lab samples, trial samples, and plant trial samples. And once they're satisfied, then it goes into the approved vendor list. So that is one part of system. But yes, as a part of supplying to customers, we know that the consistency of our product has to be very important. So we ensure that what we kind of follow, if not Six Sigma, maybe much more stringent than Six Sigma, because the product specification is much wider because we have to cater to different customers. So when it comes to handling customer expectation, we really see and focus on customer's need, what customer is looking for, and we try to maintain compliance to have a much closer CPK what they are looking for. Maybe because many customers are rating us or giving us rating based on CPK values. So if the CPK is poor, we get a low value. So we practically ensure that the customer gets the right material towards the central part of their specification. That is what is base requirement. Yes, the plant control, the SQC, SPC, and ensuring continuous improvement, optimization of processing, etc. These are the ongoing projects. But yes, with the focus that ultimate end product quality is consistent. That has been our focus. Now coming to the next point is how do we handle post production process. So post production is we ensure that the material is delivered FIFO basis. We also ensure the trucks etc. are selected on the right basis. They're practically covered with the tarpaulin etc. when it moves out of the customer godown or our plant. And we also kind of going to, or we have already started using containers for our export as well as into Indian customers, so that the material doesn't get contaminated. And obviously the kind of storage also has to be proper. We try to do that storage as well. Good control conditions. But yes, to the best possible under present condition, you have to have proper ventilated stores. That kind of scenario we have with us.
So, and can you talk a little bit about the, see, of course, every product has a shelf life. So you have a wide range of rubber chemicals, and also you in the past experience of yours, you have seen so many, issues. So can you talk about expiry periods of different types of chemicals that you supply currently, or which are the very sensitive chemicals? What are their the shelf life, estimated shelf life of those? Of course, you make sure that they store it properly. So
yeah, typically we are guaranteeing shelf life for 1 year, if not 2 years. That is one. But besides shelf life, one is how you store it. Because if you have some material which are having low softening point or low melting point, or because of the nature we make resins, so that resins starts getting self-agglomerated. So instead of free-flowing pastels, it becomes a big lump. That is where we need to be very, very cautious, and we store it not over much on each bag, and we supply in specially designed carton or paper bag so that the material stays in its physical and usable form. So we practically ensure that kind of a scenario. Otherwise, and we also in our MLTS we have mentioned that this material has to be stored properly. There's a material which is being developed, AMS. Now imagine that AMS is being imported under cold containers. So they're the air-conditioned containers being imported, and the material is supposed to be stored there, because if you keep it in open, it becomes a big lump, and you can't use it as a normal free-flowing material. So we are developing with our customers even to make it as a powder. So that's kind of shelf life scenario. Yes, FIFO, once it is exceeding the shelf life, one has to recertify that its active content, reactivity, etc. is intact. If not, it has to be reprocessed or maybe disposed.
And how do you dispose? Suppose the client buys the chemicals from you, and suppose they, for whatever reasons, they did not able to use it within the time frame. Is there any way that to take it back those chemicals and reprocess them, or anything?
That's very typical. No, that's very typical, because once you give it to customer has got the technical team also to decide, and overnight the activity is not going to change to that extent. Only thing is you have to add or maybe subtract little. Otherwise, people tend to consume, because every plant also under the governing of systems like ISO, etc., they also have to ensure FIFO is followed. So we also in plant follow FIFO for dispatch of our product. So with that, we don't overstore, as well as the customer at the same time, they also have the FIFO in practice. So we have not heard any case where the material has exceeded its shelf life. Yes, we have heard cases where material has become a big lump and customer is finding difficult. So such cases, we kind of help the customer by doing the process, because we got a batch process and we can work out and rework the material to the best of the customer's requirement. And while we rework, that time we again cross-check its properties. But that is very, very rare. I will say, in last 5 years, maybe once or twice, this kind of scenario must have taken place. Otherwise, no.
So in your experience, long experience, of course, with the TWC and before it, the various companies you are involved, what kind of bad practices you have seen when handling these chemicals? And
See, bad practices are, one is things are improving, okay, driven by systems requirement, safety requirement, employee safety, environment safety requirement. Things are really, really improvising. Like there was a time in Europe where many chemicals which are toxic, which are being used in nitrosamine kind of accelerators. So many places, especially in Europe and US, those kind of chemicals have been banned. India still is using it, but there also people have moved away because they are also exporting. So accordingly, they've reduced the use of nitrosamine kind of accelerators. So that is one. Handling safety of people in the process is again a very vital parameter. People maybe as a practice or as a kind of less importance to safety tend to bypass like lockout, tagout, etc. These are required for normal process operations. Using PPEs in the while they're working in the environment, having providing safety showers and eye washes in the area where chemicals are being used, wearing proper gloves when you're handling toxic materials. So all that is kind of I'll say less followed. But yes, things are improving and people are demanding safe working environment. So in our case also we have like we handle many chemicals which are kind of resource knowledge one which has got heavy fumes when it sublimes. But yes, we have sufficient exposures control. We have exhaust systems in place, and sufficient precautions are taken by us in our process. So that kind of scenario is there. But yes, safety in Indian organizations are improving versus the overseas organization, because I've been exposed to ExxonMobil, which is kind of on a different pole versus normal companies. So ExxonMobil is super safety conscious organization.
And do the TWC provides any training to the
Yes,
customers with reference to the how to handle the chemicals, or what kind of precautions to be taken care of, and when you
yeah, okay. TWC, yes, we do have MSDS, which is a basic requirement to be followed. In fact, that we also practice that whenever we get some new chemicals to try, we review the MSDS first, so that what kind of precautions will be taken as a preventive measures. Same way, the customer also follow MSDS. They've got their safety department, which ensures that MSDS for the particular chemicals are being followed by them in totality. And that one is a parameter. But yes, when we give it to customer, we say this material is like this. We supply all the samples with MSDS, and if there is anything special, we tell them upfront. Touch wood, there is nothing special on our material, and that thing is covered in MSDS.
Okay. Well, I think we've covered a wide range of issues related to the chemicals and the issue related to the quality aspects of it. Thank you very much, Mr. Bharat Sharma, for joining this session. I look forward to seeing you in the future sessions as appropriate for your experience and also the focus on our subjects. Thank you very much.
Thank you, Param, and thank you, listeners. Thank you very much. Thank you very much for your time. Bye.
Okay, that's the discussion with Mr. Bharat Sharma. We are about to conclude this session. I request all the panelists to come forward. Okay, open your cameras. Yeah. Mr. Parinathan also here. Please come forward, sir. Okay. Mr. Kishore. Okay. Well, Mr. Salu, are you there? Okay, Kun Salu. Okay. Okay, let's see now. We will conclude this, this panel discussion. It was longer than expected. I think we covered a broad range of issues. So thank you all, for giving input. Before we end this, program, may I ask you to give the final remarks based on what other discussion we had. Mr. EP, let's go with you first. Okay.
Well, thank you, Param. It was a quite interesting topic and most of the suppliers and many people, technicians, everybody is very curious about this subject. And you have a very good subject, and you contact many people connected with the particular rubber chemicals. It was very useful to many of the people. And views are very nicely shared here. And from the suppliers, from the technicians, everybody has shared their views. That's quite interesting. And it was also a knowledgeable, very knowledgeable session. I think you should continue doing such an important subject in future course. That's what my
Yeah. Thank you, EP. Thank you very much. May I ask Mr. Kishore Katkar? Okay, let me unmute you. So yeah, go on. Yeah.
Yeah, thank you. It was a really very interesting and very important topic for the customers as well as the suppliers. But maybe, we have tried our level best, but in future, maybe some question from the, actual users and customer will help to contribute still more, so that, ultimately we are doing for our customers. So if the question comes and if you answer, I think it will be more useful. Thank you very much. Good.
Thank you very much. Hamid, please.
Yes, I would say that today's topic was very interesting, because all of us who are doing job in this field, we face these issues quite often. And I would say there are a lot of textbook solutions and textbook remedies for these kind of issues. But I would also say that there are even more practical solutions which are not mentioned in any of the books or literature. And I would say those really work. Those practically work for us. And I would also say that one solution which works for me, that would not necessarily work for someone else, say Mr. Kishore or Mr. Samar. So this is a very tricky kind of, I would say, a very tricky kind of topic. So all the textbook solutions, they are not necessarily, successful. You do not necessarily have to follow those. You can create one of your own solution, which will be tailor-made for yourself. Maybe not for others, but for yourself. So this is a very tricky kind of topic, I would say.
It is. But I think all the speakers have given their own practical experiences, so yeah, based on their way of handling it. Dr. Samar, please.
Yeah, I would say learning from mistakes. If any customer or any supplier does any mistake, then he must learn from the mistake, and he should not repeat the same. Otherwise, it is having nothing, means value addition. So learning from mistake is the key.
Yeah. Okay, thank you. Colin, final remarks to you.
Sure, thank you. Yeah, isn't it great? You invite a bunch of rubber guys together to come and talk together. We sometimes never met each other, or in other cases didn't meet each other for years, but we can greet each other like old friends. We can align ourselves immediately onto the important topics. You allow us 90 minutes to talk and we take 2 hours, so this is always a good sign, I think. Yeah, the rubber industry is alive, it's vibrant. We have a good balance of high-level science, technology, practical recommendations, and overall, I think, like everybody said, we are here to help each other and learn from our mistakes. So yeah, I personally really enjoyed taking part in it, and yeah, would be happy to do so again. Thank you.
Okay, thank you very much. Thank you all, for joining this session. It is really a good discussion, and of course, that's what I mentioned at the beginning. I will start the program on time, but I don't guarantee the program ending on time. This is because the discussion, the issues are there, relevant to the industry. So it's important. I thank each panelist for kind contribution. And as EP mentioned, we will be discussing some more useful topics in the future with some of you, or in other topics as appropriate. Thank you all for joining this session today, for contributing this panel discussion on the rubber chemicals, quality and handling. I hope audience find it useful. Definitely they find useful. You guys brought a lot of thought-provoking points, suggestions. I'm sure that it's worthwhile for them to listen to all the ideas and suggestions. But of course, it is a pretty broad subject. There are lots of chemicals, a lot of issues, but I think it definitely a starting point for them to get some basic idea how to deal, and particularly the suggestions from all of you give a practical suggestions, not a textbook. Of course you have to go through textbook written rules as well as the nut and bolts type of management systems to manage the rubber chemicals. Once again, thank you very much for supporting this the program, and appreciate the contribution. Thank you all. Thank you very much. Yeah. Guys, that's the end of this panel discussion on the rubber chemicals quality and handbook. As you see, we have a panelist from the chemical manufacturers and suppliers, and also we have the manufacturer itself, the rubber products, rubber and compound manufacturers background, whether it's a tire and non-tire segment. So it's really a good session.